Hi everyone, welcome back to another session by K21 Academy, and today our experts trainer will be giving you a complete and holistic overview of what is Terraform, why you should learn Terraform, Terraform installation and its basics. So watch the video till the end.
What Terraform is, where it is in the DevOps, gets adjusted, where it is there, what are the equivalent other languages which are available, and how basically the Terraform features we are going to talk about. Okay, what Terraform features are. Okay, so this is going to be our agenda. So we are going to talk about the infrastructure as a code. What are its advantages? We are going to talk about the stack, complete stack. We are going to talk about the Terraform and its benefit, multi-cloud benefits, the architecture of Terraform, and how Terraform works. Okay, so basically the Terraform architecture that is in. Okay, now from the exam point of view, we are going to follow the Terraform 3.0, the latest one, because after this you are going to enroll for the Terraform certification. The new certificate is coming from 5th of April. Okay, and I will not say that it has got more topics there. Okay, because whatever the latest is there, Terraform, we are supporting it, but there are few topics which Terraform HashiCorp has removed as well. Okay, so we are going to have, so don't worry about that. So this is what we are going to cover in this. Topic one is understanding the IAC concept, infrastructure as a code concept, and then the multi-cloud and the multi-cloud agnostic benefits, what basically it means. Okay, and also we will be talking about the procedure, how Terraform works. So you will be coming across various terms there, okay, which we are going to discuss. So let's first talk about the infrastructure as a code. Okay, so just give you some glimpse about Terraform. So Terraform was there in the market from 2014 onwards. Okay, so you can see it didn't spend even 10 years in the market. And the latest release right now is one. Okay, so this is not 1.3.2. The latest is 1.4, I believe. Yeah. Okay, so the entire Terraform is written in Go language, and it supports more than 2,500 plus support providers. Okay, maybe this numbers might be not up to date. So it supports all the elite cloud providers, your AWS, your Azure, GCP, OCI, Alibaba, all those are supported. Along with that, various third-party supporters are also added in that now. So altogether, it supports lots and lots of cloud providers. So you can now see that Terraform has become the platform provider, irrespective of the provider, the platform which supports the infrastructure as a code for your automation purpose. Okay, now this is the Forbes cloud list of 2022. Okay, now here if you see, okay, 2023 is not yet released. Now if you see this list, you can see HashiCorp is at 4, and this is a global list. Okay, so you can see here now that in 2014 your Terraform got released. 2018 in the Forbes list, Terraform has make an entry at number 32. Okay, and now this is 2023 going on. It has come to top 5. Okay, and it is going to grow more. The employee strength is whatever is mentioned here is might be changed, because HashiCorp is recruiting a lot nowadays, and as they have got multiple products too. Okay, so HashiCorp Vault is there. There is Vagrant is there. So there are many tools which HashiCorp has released with the latest and the greatest versions and the features there. Terraform is one of the tool which HashiCorp provides it for the cloud automation. And apart from that, it also provides certain services which we are also going to see, uh, as a SaaS service which HashiCorp provides. Okay, it's like the Terraform Cloud, Terraform Enterprise. So these are like few of the services from the Terraform side which HashiCorp provides. Okay, so we are going to have a look of that too. So this gives you basically, some sort of excitement that okay, why people are running behind Terraform and accepting it. So that is where this is one of the reason that it has gained popularity in very less time. Okay, so first and foremost, let's understand the terminology. What basically is the infrastructure as a code? Okay, so infrastructure, whatever say you are basically doing it from the console on the cloud is you are creating the infrastructure. Okay, you are creating the database, you are creating the virtual machines, you might be adding the storage to your virtual machines, instances, whatever you are doing it, that is all you are basically dealing with the infrastructure, right? Now, from the application point of view, it is quite easy to understand that you are going to create an application by writing the code in Java or maybe in the language of your choice. You might be developing an application. But from the infrastructure point of view, if you see that okay, you are basically going to talk in terms of code for creating your infrastructure. Okay, like creating the virtual machine, you have got the code in place through which once you execute that code, a virtual machine gets created, or maybe the database might be running over it. Okay, a database instance gets created, or you can entirely deploy your 3-tier application with the 3-tier networking and all through the code. So that sounds bit exciting, right? That you are executing the code and your infrastructure with the deployments get created. Earlier, you were only focusing on the application side till now, and that was easy for you to accept it as well. Okay, but the infrastructure part where you are automating or say coding the infrastructure and then generating it. So that is where your infrastructure as a code comes into picture. Okay, where you are going to define your infrastructure, you are going to add certain amount of features over it or say the attributes of that infrastructure. Maybe whenever you are creating the machine, it should talk to the object storage, the configuration of the object storage and all those things should be always there for you. Okay, like say as your company standard, whenever somebody has asked that okay, they need a infrastructure for deploying their application, so you are going to deploy it with the company standards with all the security norms as well. So that is where you are basically coding your infrastructure and you are going to deploy it. So why you are basically coding your infrastructure? So that is because you want that is going to give you the standardization. Okay, the entire cloud, if you see, is about the standardizing your what you were doing it from on-premise. Okay, so whatever you were doing it on on-premise, you are having full freedom on that to use the things, use the stuff in your own way. Okay, as per the organization standards. But now with cloud, you are basically moving from your organization standard to a generic standard. Okay, like on the cloud, you can have a operating system of certain versions only. Okay, the latest and the greatest. If you want to have an old one, then you can still have it. Okay, but there will be more complications in that. So the main thing is to standardize your requirements or say to standardize the infrastructure side so that everybody will be getting the same thing like your Gmail account. Okay, everybody gets the same login, the same interface. You can bit change the color and the look and feel, but the feature wise it's all the same, and exactly the same thing you will be getting it from the infrastructure as a code as well. So it is more about the standardization. So you are now going to say define and provision your infrastructure. You can manage your infrastructure. uh, you don't have to worry about like how you are going to reach to the infrastructure state. Okay, but you should know that okay, what is the end state of your infrastructure. And yes, till now you were not having any kind of documentation, right, of your infrastructure, whatever is there. But now with this infrastructure as a code, you are basically documenting your infrastructure. Okay, now you can use infrastructure as a code for your cloud. Okay, that you can easily understand. Okay, But for your on-premise infrastructure also, you can have the code in place. Okay, like if you have got any interface there or have developed any interface, you can register all those things as an HashiCorp under the HashiCorp name, and you can integrate that with Terraform too. So as a provider, your organization can create a provider and can use the infrastructure automation of your on-prem infrastructure as well. Okay, it is just not always the cloud, but your on-prem can also be coded. Now, why I have highlighted in yellow is because this might be one of your true or false kind of questions in exam. Okay, so if your infrastructure has got an programmatic interface there, then you can have an infrastructure as a code. So infrastructure as a code, Terraform is part of it. Okay, there are many other languages as well which are part of the infrastructure as a code. Right now we are talking about the IAC. Okay, but when you should use IAC? Now if you have an enterprise level organization, say, is there, which has got large number of infrastructure. Okay, every now and then, like multiple departments are there, some or the other activities are going on, maybe from the financial side, from the supply chain side and all, lot of activities goes on. And for running each and every activity, definitely some sort of virtual machines and the infrastructure is always needed. So you have got a large footprint of the infrastructure. If that is the case, then IAC is going to be boon for you, because even if I say you are spending time from the portal, you can say that, okay, I can create infrastructure from the portal itself. That is more easy for you. But if you see just creating a single virtual machine, you will be spending time, whatever time you are spending, okay, less than half of that you can directly do it from the infrastructure as a code. Okay, like simple launching a virtual machine in your portal, that might take at least say 1 to 2 minutes till you invoke it. You might need to give certain parameters, certain things there. But once you have written the code, you just have to execute it, apply it, and within seconds your infrastructure will get created, because it works in parallel. So that is where you are going to save a lot of time. So whenever you have got say large amount of resources on the infrastructure side, you can standardize it, you can create a template, you will not be missing anything from the security standards as well. So that is where infrastructure as a code can be very much helpful there. Now, multi-cloud is what the trend is going on, that a single cloud provider is not sufficient for any organization. So they might be, going with multiple cloud providers as best of all, best of to get the best of whatever they are providing or they are working on. Okay, like for the database, Oracle is the best one. Okay, you get Exadata services there, you get a lot of things there. So that's why you can see that Azure and Oracle has got the tie-up as well. So that is where you will be seeing that multi-cloud is the new trend. But if you are going on the multi-cloud thing, you need to have a single interface which manages the infrastructure on both the sides. And that is where infrastructure as a code comes into picture. Okay, apart from that, yes, you might want to make a regular adjustments in the infrastructure. Now these regular adjustment might be, you need to patch your infrastructure with the security patching, maybe quarterly or so, or maybe come up with any kind of ad hoc patching which might be there, or might be the patching which might be you will be doing it from the application point of view as well. So those things are there. And as I mentioned, that infrastructure as a code is a kind of documentation you are going to do it for your infrastructure. Okay, so Terraform, or say infrastructure as a code, gives you the documentation of your infrastructure, and you will be able to, and yes, multiple teams can collaborate and can work there. So these are like few points which I will say that, okay, the highlighted points that why you need infrastructure as a code. Okay, now apart from that, you might be having some specific requirements as well, or some specific scenarios as well, where you will feel that, okay, yes, infrastructure as a code is going to help you there. Okay, like a simple deploying your continuous integrations and the continuous delivery. For that purpose, you might need the infrastructure as a code so that you can automate end to end, right from the infrastructure till the application deployment, and then further testing and all those things. So that is going to save time. More standardization will be there. You will be less prone to errors, right? So that is basically where like you will not be the alone who will be part of the project. It will be like administrators who will be administrating the infrastructure, or there will be developers who are basically part of developing the application and the deployment as well. So it is a collaborative efforts for any project to get successful. Okay, so right from the infrastructure side, okay, you are basically going to collaborate as a developer. Okay, there will be a collaboration between the developer and the administrator. So you will be, say, dealing with the infrastructure provisioning. Okay, provisioning the infrastructure, and then further you will be deploying the application over it. Now those applications are there now on which further the deployment, say, if it is a WebLogic based application, then the deployment of your war file and ER file will be there. So that will be taken care by the development team. Okay, they might be doing their testing, they might be making the changes, making improvements, fixing the bugs and all. So infrastructure as a code is going to be the joint efforts, okay, where the developers and the administrators are going to collaborate, right? So something like this, on the infrastructure as a code you can expect. So there will be a developer. Okay, now these developers are the one who are basically writing the code, okay, or maybe writing the code for the deployment purpose. You will be the one who is going to write the code, or say do the stuff for the infrastructure side. So everything will get collaborate, like the combination of Terraform and Ansible. Okay, I will explain you that. Okay, what basically is the Ansible and Terraform are basically have got the features there. Okay, they are basically two different categories, but how that can be collaborated from the development and the administrator point of view. Okay, so how things works together. Okay, now that is where your configuration management comes into picture, where you are going to manage the configuration or the deployments of your application over and above the infrastructure. You can use either the push or the pull of the code there using the APIs, so application program interface, REST APIs and all. That is what you through which you are going to interact for the automation purpose. Okay, and then you are going to have an infrastructure, either infrastructure of your on-prem, or you can have a deployment, or say the management there for the on the cloud as well. So anywhere you can use it. So that is a deployment automation. You will be doing a lot of testing. You are going to have the version control too as ever, so that you can track the changes whenever there is a change, a new version gets created, so that you can see that, okay, what changes were there from the previous one. So infrastructure as a code has got all these five. I will say that as a broad level, these all are part of the infrastructure as a code. Okay, and we are basically going to talk about the infrastructure automation where Terraform falls. Okay, now you will be wondering that, okay, then why configuration management is not basically part of this. Okay, so we will understand that difference, that okay, what is the configuration management and what is the infrastructure automation part. Okay, so that is where we will be learning with an example of various other cloud providers or cloud automation tools like Puppet, Chef, SaltStack. All these are there, and we have got how Terraform is a bit different from these tools. Okay, infrastructure as a code is imperative. Now imperative means what? Imperative means if I ask you to reach out to say any place, like say Eiffel Tower in Paris, if I ask you, then I will be giving you the entire direction, the left turn, right turn, you are going to take the flight, and then once you reach to Paris, from there, how you are going to move on. So that means you are going to give the specific commands and steps that how you are going to reach to the destination. Okay, so that is basically about the how you are going to talk, procedural one. So which basically focuses on actual process, how the provisioning works, and how you are going to reach to the destination. So that is what your imperative means. Okay, now this is basically the type and terminology which you are going to come across your infrastructure as a code. But what is the another one? The declarative, which basically defines the desired state only. That means I have asked you to reach Eiffel Tower, whatever way you want to reach it out, you go ahead and do it. Okay, but I will be more interested in the end state, that what is basically the end state of you after say 10 hours, how you reach to the destination, to the Eiffel Tower. That is what my my objective will be. So that means, so I will be focusing only on the desired end state. Okay, and will not be worry about like how you reach. You can reach directly to me, so I will be only giving you my address, that okay, this is going to be my address. Now you can come via train, you can come via bus, you can come via car, you can come via walk, whatever way you want to come to me, that is your choice. Ultimately, I will be only looking that, okay, you have arrived to my place to meet me. Now that is the declarative one, there where you are only, focusing on the desired state. So these are basically two terminologies which you will be learning, or you will come across about various infrastructure as a code when we are going through that, how you have reached to the destination. And these are basically the fundamental concepts which you will be you need to learn, right? Okay, now we'll be covering the context about the declarative and the imperative in a while. Okay, but before that, let's understand the advantages of the infrastructure as a code, which we already have gone through that many of them. But yeah, let's have a broad overview of that. So repeatability. Now in, if your organization has got standards, then you will be doing the same task again and again. And if you have got the code in place, like in during your college days or school days, you might have learned that, okay, you want to generate the prime number from between 1 to 20, the first 20 numbers, how many prime numbers are there. Now that has been the expansion, the horizon got expand, and somebody have asked that, okay, let's take not go with first 20 but say first 50, then it comes to first 100, and somebody has asked that 1000. So you are basically doing the same kind of activity again and again. Now the best approach will be, you can just write a code which accepts the end the end limit. And somebody says that, okay, I want a code of first 10,000, just write 10,000 and it should be giving you display all the prime numbers there. So the same repetitive task which you are doing it again and again, you have basically write a code of that, and now that task can be done within seconds. The calculator and everything, like these are like all the things where most of the repetitive operations which you are going to do can be automated. And infrastructure as a code is basically the same. Speed. Infrastructure as a code, whatever languages are there, they works in parallel. So whenever you write a code and execute it, it starts executing in parallel, and that is where the speed comes. That is where the infrastructure as a code will be dealing with the stuff pretty quickly and fast. Documentation, that is what we have seen, that for your infrastructure you are now going to have a documentation. Maybe you can keep it for the audit purpose or so. Version control is there, so whenever there is a change, the new version gets generated, so you will have a complete track of the changes in the infrastructure. Validation, you are going to validate your infrastructure as well before you make it live. So you have got one level of check where you are going to validate your infrastructure as well. And yes, the reuse, so wherever you want to make create a similar or say standardize the organization needs, then yes, you can reuse your code for say creating the virtual machine, for creating the network deployments. So for many things, the security standards, everything, you can just reuse your infrastructure as a code. So if I want to say categorize my infrastructure as a code, I will be categorizing the tools which are available in under 4 categories, which are like pretty much covers all the aspects there. Now infrastructure as a code, as right now, I think since you are basically working on the infrastructure side, so you might be using the shell scripts, or you might be using some ad hoc scripts for various kind of automation, right? Okay, suppose if you want to schedule a job, then you will be using say the shell script, which is scheduled by a cron job and will be running at the desired time or whatever schedule you have mentioned. So that is again comes under the infrastructure as a code tool as well. Then you have got the configuration management tool. Now configuration management tools are basically the one which you will be deploying it over and above the infrastructure. Okay, like suppose I have an infrastructure in place, a virtual machine. Now over and above that, I am deploying say Apache server over it, or maybe the WebLogic server over it. So that is basically you are managing the configuration over and above the infrastructure. So that is known as the configuration management tool. Then you have got the server templating tool, like I'm going to create certain infrastructure, say the virtual machines or so. Templates are there. I will be just giving my inputs there and creating it. So that are known as the server templating tools, and there are some pre-built templates which are available through which you are going to deal with it. And then you have got the server provisioning tool as well. Okay, so these are basically the one where which are purely used for the infrastructure creation. Okay, so you have like various tools which are available within the cloud provider itself, or there might be some global tools which is going to get associated with any cloud provider. Okay, so let's have a look on few of the tools which are available. So infrastructure as a tool, say the Vagrant, which is again developed by HashiCorp only, where you are going to use Vagrant for building and managing the virtual machines. Okay, so there are templates which are provided. If you see the snippet here, this is the Vagrant file in which you are going to define everything there, like what operating system you needed, what ports needs to be open, and what folders are needed. So those you are going to define it in the configuration file, which is known as a Vagrant file. Okay, and then you are basically going to create your development environment. So this is basically the tool which is used for mostly for the development environments, and it is, I will say that, not purely configuration management tool. It is a bit say created or I will say that, okay, not a complete configuration management tool. This is more like creating the development environment, the virtual machines or so. So this is for those purpose. So you are basically going to create and manage the virtualized development environment. So this is basically the process of setting up and configuring your virtual machines, or say the containers which are there, and make that the process completely consistent and reproducible for various platforms. So Vagrant basically works as a virtualization provider for VirtualBox, or say the VMware and the Docker. For all these things, your Vagrant works. So this is used for that, and it has got a file over there. You can integrate it with Ansible, Chef, Puppet for provisioning and configuring your virtual machine. Now configuration management, as I mentioned, deals with the deployment of the application over and above the infrastructure. Okay, that is where the configuration management comes. Infrastructure provisioning is basically the one which deals with the infrastructure standardization itself. Okay, where you are going to create the underlying infrastructure, and then over and above that, when you are deploying any application, that comes under the configuration management. And Vagrant is basically more towards the configuration management. I will not say it is a pure configuration management, but it is more towards the configuration management. So Terraform, which is basically one of the infrastructure as a code tool. Okay, and now you know that, okay, the Terraform, you can use it for the infrastructure provisioning. Okay, if I say talk about other tools like Ansible or Chef or Puppet, they have got the infrastructure orchestration and the provisioning capabilities, okay, but that are not well developed. Okay, like I can use Ansible for creating my infrastructure as well, for provisioning my infrastructure too, okay, but it doesn't have all the capabilities of managing it. Now Terraform is basically the tool which has got all the capabilities of infrastructure provisioning and infrastructure orchestration too. So you can use Terraform for your complete deployment, end to end. The infrastructure deployment, you can use it. And then for the configuration management, you can use other tools. So that is where your Terraform and Ansible comes into picture. Ansible is also, like, the most commonly used tool from the configuration management side, which basically deals with anything you are going to deploy over the infrastructure. So Terraform has got all the capabilities, and even, like, now has been, more features are getting added to it. So it has got all the concepts and all the capabilities which are needed for the infrastructure provisioning and the orchestration. That is where it lands. And that is where we are going to learn Terraform from the infrastructure provisioning point of view. Okay, it follows certain methodology as well, which we are going to see it soon in next a couple of minutes. That what is the philosophy of Terraform, what is the fundamentals of Terraform, and where it is going to give you the why it is going to be the best tool for the infrastructure provisioning. It has got the concept of provisioners as well, which is the concept of more towards the configuration management philosophy, but it has not been developed that much. Even Terraform says that, or HashiCorp says that you can keep that provisioner, which is more towards the concept of configuration management as a last resort. Okay, we will see that, okay, what provisioners means, and why that is being avoided in Terraform for the deployment purpose. But for the infrastructure provisioning, there is no tool which is better than Terraform till now. Okay, the new features, the new versions, bug fixes, all are going in parallel. You will see that a lot of changes are coming with each version of the Terraform. So those are all in place, but there is nothing, a pure tool which manages the infrastructure other than Terraform. So Ansible. So Ansible is again, the open source software provisioning, okay, configuration management, and the application deployment tool. Now, if you see here, the definition itself says that it is not used for the infrastructure provisioning. It is used for the software provisioning, not the hardware provisioning. Okay, so this is one of the configuration management tool, which is used for managing your all the configuration over and above the infrastructure. And if you see on the right hand side, this is basically the YAML file in which you are going to define the state of your infrastructure, what you need it, okay, and then over and above that, what needs to be configured, what ports needs to be open, what is the end state you need it of your software deployment. So that is where you are going to define it. So it uses the concept of playbooks, which you define it in the YAML file, and then you execute this YAML file for your infrastructure provisioning, or you can even use it for your configuration management. That means over and above the infrastructure, or already provisioned infrastructure is there, over and above that you are deploying the software over it. So this is where you will be using Ansible. Okay, now if you see the entire thing, as you are now having a clarity, like what Terraform is and what Ansible capabilities are. So Ansible was never created keeping infrastructure in mind. It was always developed as a software provisioning tool and used as a configuration management, which is going to be over and above the infrastructure. It has got the infrastructure provisioning capabilities as well, but not as robust or as dynamic as Terraform is having it. So that is where your Terraform and Ansible goes hand in hand, where you will be using Terraform for the infrastructure provisioning, and over and above that Ansible for your configuration management. So that is how both goes hand in hand for entire end-to-end deployment of your hardware and the software. Similarly, from years together, we were using Chef as well. Okay, which is again a configuration management tool where you are going to have the recipes, you are going to have the cookbooks there, and it uses the Chef server to store all your recipes and the cookbooks there, and then you will be using it for the deployment purpose. Right. So if you see here the code which is there on the right hand side, this is the code written in Chef. Okay. So it uses Ruby as the language at the backend. Okay, where you are going to define your all the status of your software, whatever you want it. Like here, if you see the Nginx server, you are going to install and configure it to, okay, the owner groups or what should be the permissions there. So that is what you are going to define everything, and then this is going to deploy on the infrastructure. So everything, if you see here, over and above the infrastructure, it is working. Same thing, like your Chef, you also have a Puppet language, okay, which basically is the popular tool for the configuration management. Again, it uses the client server model, and it uses the manifest file for installing. So here, if you see this code, this is in Puppet, which installs Apache web server and make sure that it is running. So it has got the classes, the manifest file, the catalog modules there, which is in line with the infrastructure as a code concept. Okay, and this is basically the agent-based tool where you are require an agent which needs to be installed or deployed on the target machine before it starts communicating with the Puppet server. So this is a quick comparison here, under the categories. So you can see here, it uses the HashiCorp HCL, and your plugins basically are written in the Go language. Okay, for the Terraform, it uses the HCL language, or it can also use the JSON format. Okay, that means you can also write it in the JSON format if you are comfortable with that. And HCL is there, HashiCorp configuration language is there, which is a pretty easy one, and that has got all the details in it. So that is there it uses. But for say your communication with the plugins and all whatever is created, or even the Terraform binaries, which if I talk about, that is written in Go language at the backend. Okay, so all these comes under the Terraform, say the configuration management. Only Terraform is the one which is purely developed from the infrastructure provisioning and the infrastructure orchestration point of view. Okay, now these are basically all deal with the mutable infrastructure. Okay, only the Terraform is the one which deals with the immutable. What does immutable and mutable infrastructure means? Okay, just give me some time, I'll be coming to that. Okay, and if you see the approach for the Puppet, Chef, Ansible, and SaltStack, these are like having a combination of say the declarative and the imperative. Okay, now if I talk about say that okay, it is a declarative and the imperative, you will now understand that okay, what it means. So Terraform is basically the declarative one. That means it only depends on the end state of the infrastructure. Doesn't matter like how you are provisioning the infrastructure, but it deals with the end state only. On the other hand, Chef, Ansible, SaltStack, all these are also having an imperative mode as well. That means you need to define the path that how you are going to reach to your end state. So that is what imperative means. Okay, so now you might have come across various vendors. Okay, and these are the most common one: Azure, AWS, OCI, Oracle Cloud Infrastructure, and the Google Cloud. Now, these has got their own automation languages in place with them. Okay, like Cloud Formation is basically for AWS. Azure Resource Manager, ARM, is basically the templates which are used for the Azure infrastructure provisioning. Google Cloud Resource Manager is basically used for the Google Cloud. And resource manager, there is a resource manager which is for the OCI. Okay, now these are the cloud vendor specific automation tools which you can use it for the specific vendors only. But now if I say that multi-cloud is what the new norm is, In that case, for managing the AWS, I have to go through the cloud formation. Then for managing the Azure, I have to go through the ARM. That means I need to manage two different tools, right? So this is only having the scope within their cloud provider. Okay, you can't come out of that and use it for the multi-cloud. So that is where your cloud, your Terraform comes into picture, because it is the cloud agonist tool which is used by all the cloud vendors in the similar way. You need to define the provider and start working on it. So Terraform is independent of the cloud provider, can be used for any cloud providers for the deployment and the for the infrastructure provisioning and the management purpose, and has got various providers available, almost 3000 plus, and that is where the Terraform is supported for all your cloud providers. Even you can have multiple providers as a part of your multi-cloud deployment strategy too. So in that case, you don't have to worry about whatever is locally available within the cloud provider. You can have it and manage it as a globally you can manage it using the Terraform. Okay, now what basically the Terraform solves? Okay, the first is the time, the lead time where you require to build the infrastructure and all. If we go back to the old days where you need the provisioning, it requires even months together, because you need to put a purchase order in place for provisioning, for procuring your infrastructure, and then when it arrives, then all the standard integrations and the configurations will be done, then the operating system will be installed, and then you will be getting the infrastructure ready for your purpose. Okay, but that is all going to be the fixed infrastructure. Even if you don't have that much requirement, you have to go minimum with that, right? But now when the cloud comes, and then over and above that, if you get a Terraform, then you don't have to worry for that months or weeks there, right? You can get the infrastructure within a day, or if you are following all the norms, or within couple of hours, you can get your infrastructure ready with all the requirements. So Terraform reduces the time to build. A human error, when you are doing the things in the repetitive way, or say you're doing the manual way, there is a lot of chances of human error. You can't track the changes earlier, but now with the Terraform, if you have the versioning enabled and all the changes can be tracked. You can replicate the environment, you can rebuild the environment, and you can manage almost all the resources. So there was a thing which was asked about, like, what is the difference between the reuse and the rebuild? Okay, so I would like to cover that again. Okay, that what basically the repeatability is there. So repeatability is like, suppose the same machine I want to deploy and use it for my various deployments. The same thing I want to deploy. So there I should get the consistency. Okay, and it should be predictable that this is how your infrastructure is going to be there, and this is how it is going to manage. So that is basically the repeatability, that you are getting the consistent performance on the when the same infrastructure is used. Okay, like say even when you are doing the patching and all those things, even that also you are following the process, and the same thing you are going to get it in the same way. You do it multiple times, you do it 100 times, you will get the same result. Okay, so that is basically known as the repeatability. But reuse is the code reuse, where you are going to use the same code for generating the same infrastructure. Okay, so that is where the Terraform helps and gives you the predictable and the consistent performance, right? Now let's have a quick high level overview of Terraform. Okay, so Terraform as a cloud provider, we are going to start with that. We are going to initialize our cloud provider, whichever cloud provider you are comfortable with. And for me, I will be using the Azure cloud provider for my reference purpose and for the examples. Then we are also going to talk about the resources. Now each cloud provider has got multiple resources in it. Okay, like your virtual machine, storage, object storage, networking, firewalls, all those things are there. And each of this resource is basically from the cloud provider and is having a APIs. So that is over the API they communicate, and you use for dealing with various resources. So that is what we are going to set up, and we are also going to perform all the activities which are needed. So that is what your resources means here. Now, apart from that, there are various configuration files through which you are going to communicate that, okay, what kind of desired state you want for your deployment, for your infrastructure. And that is all defined in the configuration files of the Terraform. So you are basically going to give your input via configuration file to the Terraform execution, binaries, and then that code will be read and understood and compiled by the Terraform, and the required action will be taken. So that is all we are going to define it in the configuration files. To make our code more dynamic, more robust, we will be using variables. Okay, so instead of hard coding the stuff, we are going to define it as a variable and make sure that our code is reused. Okay, so just changing the shape will give us basically the required virtual machine configuration. So that is where the variable comes into picture. We will be seeing uh, all the variables. Terraform has got a rich variable set available, and it supports a lot of different kinds of variable too. So we are going to see that, okay, how these variables are used, and where to use these variables when it is required. So that is what we are going to cover as a part of, so example of the entire all the variables we are going to see and understand that, okay, how variables can be used and what is the precedence of these variables when you need to pass which kind of variable, and what should be the output you will get it when you are passing the variables in different ways. So that is where you need to understand the loading of the variable and the precedence of the variable. Then we are going to talk about the state file, which is, say, I will say, one of the very important aspect and is heart of the Terraform, which maintains the state of your infrastructure after the provisioning, that what state is there, and in case if there is any changes you are going to do it, how it is going to behave. So a state file has got many details in it, and the entire security and the management of the state file is very much needed, so that we are going to cover it. Then the data source. Data source are something which you have already created. Like suppose your organization has already created the infrastructure via console, cloud console. Okay. Now you don't want that infrastructure to move it to the Terraform, but whatever the next is there, you want to use the existing infrastructure as well. Okay. So in that case, what you can do is you can create a data source and can use the infrastructure which is not created by Terraform, which may or may not be created, not necessary, or maybe something like you have got various data centers available in the cloud, okay, which might be known as the availability zones or availability domains accordingly, which cloud vendor only has created. You don't have any hold on that, and you are not the one who are going to create it. That are existing ones, and you want to deploy your applications and define the high availability or DR kind of scenarios using those availability zones, or say the regions, so that you can create the data source and can use it in your infrastructure as a code. So that is where your data source comes into picture. Very important concept, which we are going to see it with example. How you can modularize it, like this is again one of the basic which you are going to use it for the in code reuse. Okay, instead of say uh, creating the VNet multiple times, what I have done is I have created a module and I'm calling that module multiple times. If you guys have gone through any of the language in the past, okay, see Java or C or C++ or something that has got a function, concept, where you are going to define the function which has got an input and the output, and you are again and again calling that function at multiple places, right? Exactly the same way which is there for the modules as well. So we are going to see and learn about it. Then Terraform has got a concept of workspaces as well. Okay, where you, when you want to deploy it using the instance strategy, like I have got development, production, test, and multiple, instances I have. Now, how I will be maintaining the same code and will be managing multiple instances. So that is where the workspaces comes into picture. Provisioners. So as I was talking about the configuration management, provisioners are basically in line with the configuration management concept. They are not in accordance with the Terraform philosophy. And that is where it has got a bit diversion from the infrastructure as a code concept as well here. Okay, so we are going to see about it, but yeah, as now this is not going to be part of your Terraform 3.0 exam. Okay, they have removed this provisioner section, so we will not be spending much time, but yes, I'm going to give you a complete code and how it is going to use, what are the usage of that. We are going to cover that, even though if it is not a part of exam, but yes, we are going to cover that. Various security features which are there, that how these security is going to be there, how you can manage, how you can secure your infrastructure as a code, what are the best practices. That is what we are going to cover from the security side. And then the Terraform and Enterprise and the Terraform Cloud, which are the offerings which are provided by HashiCorp. We are going to see that. That is again a very interesting concept of Terraform Cloud and Terraform Enterprise. And yes, of course, the overall best practices we are going to see. Right. So this is a high level of Terraform, how uh, Terraform looks like, or say the high level concept. Now this is my Terraform. These are all my configuration files here. So these are like all my configuration files. This is my state file. Okay, I am using, this is my say Terraform binary. So all these are the inputs to my Terraform. And then once you are executing or compiling it, this is all going to provision the infrastructure with multiple cloud providers, where whatever you have selected, that is all going to be part of it. So this is how your Terraform is going to work, right? Okay, so Terraform is written in Go language. It is used for building, changing, and versioning the infrastructure. You can use HCL or JSON format, anything as an for writing your configuration file. Okay, and it has got various extensions which is there for the configuration files. We will see that too. The configuration files are written in .tf format. Okay, that is the Terraform extension, but there are tf vars and other extensions as well. So we will see that, okay, where it is used and what all it is there. Then when you are basically done with your code, you can do the dry run of your code as well. So that is where it is going to generate the plan that, okay, what it is going to do, but it will not actually do that. Okay, it will just do the mock run of your code and will show you that, okay, once this is actually executed, this is what it is going to create. Okay, and then if you are satisfied with that, then you can go ahead and apply that too. So this is what we are going to see in the Terraform. And yes, Terraform is used for the multi-cloud cloud agonist tool, as this is going to behave in the same way for any of your cloud provider. You need to write the configuration files. It is going to perform the API calls with the cloud provider resources, after the authentication, and then it is going to deal with it, right? So that is where your Terraform works in the same way with all your cloud providers. So Kubernetes and all those has been recently added. Okay, as a provider, you can see that too. So for, like, say you want to have an AKS or EKS deployment, you can have multiple options now. You can use Kubernetes services as well. You can use the EKS services or AKS services too, as a provider under the AWS and Azure, and can use it for the deployment purpose. Okay, now I have mentioned some time back that Terraform basically deals with the mutable and the unmutable infrastructure. Okay, so what Terraform actually is? So Terraform is basically the immutable infrastructure. First, let's understand that what is the mutable and what is the unmutable infrastructure. Okay, now if you see from the diagram, okay, I am having a infrastructure as a code here. Okay, and I am provisioning, say version 1 I have provisioned. Okay, after few days, when there was a say a quarterly patching or something is done, okay, I applied the patches on the same infrastructure. Okay, maybe after another quarter I have applied it and created a version 3 there, and that is the place where my actual application deployment and the infrastructure at the start, say I have started with certain version, my versions get differ. Means I'm getting drifted from the actual infrastructure version and the application version. Okay, and after some time might be my application stop working because of the incompatibility, and I am troubleshooting it. Maybe I might take more time to troubleshoot it, or I may not be able to detect it because it is, I have come too far where it is, now impossible for me to make my application work. So that is basically the drift which has occurred, where my application versions are at the older versions and my infrastructure I have applied patches and have come to the latest one. Or there is a version incompatibility there because some components I have applied the version and some components are not applied, which are not compatible with the infrastructure. Okay, so that is basically what you were doing it, till now, or maybe on your on-premise you were dealing with that. So that is known as the mutable infrastructure. What is then the immutable infrastructure? The immutable infrastructure is, if you see on the right hand side, you are provisioning version 1, then some changes are there, and you might have to apply the patches. You are not applying it in place on the same infrastructure. You are creating altogether a different infrastructure and then applying on that, so that whatever the version incompatibilities are there, you are going to sort it out and then come to the live model. Till that time you are not disturbing your existing infrastructure. So that basically gives us more flexibility, more consistency on my deployments and my infrastructure. Just an example, I have got to apply, say, the security patches at the OS level. Okay, the first thing, I have created an infrastructure and my say, so suppose on version 1 I have created, which is going to have an operating system, and say application version 1. Now after 3 months or 4 months I am applying the security patches at the OS level. So what I am doing is I am going to create a new, altogether a new infrastructure with the version, and then applying my patches v2, or say all the patches I am applying it and creating a version 2, and then deploying application on that, and see that okay, whether those applications are compatible or not, or maybe if anything is required from the application point of view as well to upgrade it to make it compatible. I am doing that and then deploying it. I will make that created it separately live, make it live and will be decommissioning the version 1. Okay, I am not doing everything on the same infrastructure. Okay, because that might make some components compatible and some components might not be compatible, right? So I have to design my infrastructure right from the beginning, keeping that in mind, that okay, how I'm managing it. So say my deployments which I am doing it, that will be all independent of the IP addresses. Okay, they might be using the virtual IP address, or maybe the host name, binding and all those things will be very fast there, so that I can maintain my infrastructure and my configuration management incompatible to each other. Okay, and it is not going to disturb my application URLs or anything there, or deployments, whatever it is not going to impact that. So that is how my strategy should be. Okay, and that is how I'm going to use my infrastructure level provisioning on the cloud, or maybe on the on-premise, whichever it is. So I will be having my strategy completely there with the dev, test and all, and along with, and that is where the DevOps comes into picture. Your development team will also be working along with you whenever the infrastructure you are upgrading, they also needs to be in place with that. That is where the coordination comes into picture. Okay, so yeah, don't worry much about it. I'm not going to show you that how it works right now, because before that we need to just go through certain other concepts as well. Yeah, so this is a classic example of Terraform and Ansible. So Terraform, here you are using it for the infrastructure provisioning. Say I have used the AWS cloud provider here for provisioning this, and depending on what is the end state of my infrastructure, I am using then the Ansible playbooks and everything for the configuration purpose. So this is where I am going to deploy, say, application over and above this, virtual machines, or say the EC2 instances which has been created. Okay, so this is how your Terraform and Ansible goes hand in hand together. Okay, so Terraform independently you will be using it for your infrastructure side, and Ansible or maybe other configuration management tool, whichever you are looking for, you can integrate that with the Terraform for the configuration management. Terraform installation. So we are going to deal with, so you can basically, understand this way, that you are either be on the Windows, like me, I am on Windows, where I'm going to, start doing the installation and doing the setup. You can be on Mac there. So Terraform installation, so Terraform binaries, we are going to take it, okay, from HashiCorp side, which is written in the Golang language. Okay, Go language, that is what it is. And what HashiCorp does is it gives you a compiled single binary, which you can use it for your multiple operating systems as well. Okay, so there is no dependency there. It basically, you just need to go to the site and see which operating system you are using it and download the binary. You don't have to install. Okay, the first and foremost is, okay, the challenge is, people will come and say that, okay, I don't have an admin privileges, I don't have the rights to install anything on my system or so. Don't worry about it. You don't have to install, you just have to download it. Okay, so Terraform setup is just, you need to download it and then perform the setup. Okay, that I will show you for what it is. So Terraform, you can download it from terraform.io downloads, and that is where you can see the Linux or whatever the binaries you need it. So that compiled version of binaries are provided, say, on the Linux, on the Mac OS here, and on the Windows. These are the three setups there. So on the binary, on the Linux, you are going to download, say, 3264 or ARM based processor, whichever it is there. You can download that. On the Mac, okay, again, when you go to the site, okay, and on the setup part, it will say that, okay, you need to install, Homebrew on the Mac OS, for which is basically the open source package management system. And then using that, you are going to install the Terraform. Okay, but that is again completely optional. You really don't have to do that. What you need to do is download the Terraform binary. Even like on the Windows, if you see, they will say that, okay, you download the Chocolatey open source package management system. Okay, and then using that, you go ahead and do the installation. Okay, don't don't I mean, means it's good to have to go with this way, but it is really not required, and that's why I have kept it as optional. Okay, so remember, that is all optional thing. Terraform download for Windows. Say I'm using Windows, and this is where the install Terraform comes. Now here you are seeing for which operating system you want it. Like, say I want it for Windows. Here I will be downloading it for 386 AMD, whichever this is there, 64-bit. So I say download 64-bit. Okay, and now this is all downloaded here, Terraform. So what I did is I have created one folder with Terraform, and this is where my file is downloaded. Now this is a compiled binary. You can just uncompress this, extract all. Okay, now this is, you just need to extract this binary. I have extracted it here. Okay, so now you can see the folder, and this is my compiled Terraform binary. Okay, I don't have to really install this. Okay, what I need to do is I just have to copy the path, go to my environment variable here and put that in the path. Okay, so I just say edit, yeah, new. I just put that in the path, and I have an old one as well. I delete that. So now I have just put the path of where my binary is located in the environment variable, path variable. That's it. I have not installed anything. The pre-compiled binaries I have downloaded. and kept it in the path. Now, if I want to check about my Terraform version, so it should now recognize my Terraform. You can see while I'm giving the Terraform, it is just asking me, giving me the options. And if I want to see the version, which Terraform I am using, so you can see the Terraform version 1.4.4 is what I'm using. When you are starting your Terraform journey, always download the latest version. Okay, later whenever there is an upgrade or anything there, then we will plan it and see, how the upgrade happens. You don't have to worry about that. But whenever say you are starting your Terraform journey, download everything latest and be ready with that, because that is your base from where you are going to start. Okay, so now you are just, even though if it is your Mac or anything there, just download the binary, keep it in the path, finish. For Linux, you can just export the path and add that in the path, and your Linux setup will be done. We are not installing Terraform, we are only downloading the binary and keeping it in the path. So this is where my, and yeah, so the environment variable, you need to go to, oops, yeah, so edit the variable. You can see the path variable defined for you. Go ahead and edit it and just put the path. So this is what my path is. Okay, it is not including the binary. Okay, it is just the path where my binaries are kept, and I have just added it, new one, or edit it, and that's it. And then start the CMD and see what basically is the version. So this is basically now the Terraform is means whatever code you are writing, your system will understand that, okay, this is what it means. Okay, basically it is a compiler which understands the JSON language or say the HCL language for your code. Okay, whatever you are writing it, right? Let's move further and see what next it is. Okay, now we need to have an interface where we are going to write a code, and that code will at least will be having a format there, or at least it should be we should be able to understand while we are going through the code. Okay, now there are multiple interfaces which are available. Okay, and like Atom is there, or even you can use it Linux also, your vi editor, and create a file and just put it there. But to just have an ease and to understand it better, we use the Visual Studio Code. Okay, now that needs to be downloaded and installed too. Okay, again, this is the choice. You can have in Visual Studio Code, or you can have a Linux virtual machine created in your cloud account, and you can use that for your all the coding part for the Terraform, and can invoke other infrastructures via that. So whatever is there, that is all your choice. This is a recommendation that you can use the Visual Studio Code so that you can have a better interface, more uh, extensions are there, and you can get online help there then and there itself. Okay, but yes, you have your own choice. You might have worked in the past with some another coding tools as well. You can use that if it supports your Terraform and all. But yes, Atomic, Visual Studio Code, and uh, many others are there, which are quite good and gives you a better interface there. Okay, so I will be using this Visual Studio Code. Now this is how it looks like. Yeah, exactly. Layout is better. Okay, so let me just go to open folder. Okay,
Hello.
so what I will do is I will go ahead and create a folder, and then I think that will be a better one. Yeah, so let me create a folder. So I will be say creating a folder tf, right. So now this is say I have set up my folder. Okay, it will just ask you that, okay, trust there. I said yes. So this is going to now give you a good interface. Along with that, I can start writing my code here. So this is, I have just, created a folder where I will be putting all my Terraform Azure related codes, right? So this is where we are setting it up for our infrastructure. So let me just, show you how the file extension will be. Yeah, this is my working directory. And Terraform Azure, I'm just say creating my first code. I just have created another folder there. Now in that, what I'm going to do is I'll create a new file, say provider.tf. So if you see, I have written the tf extension, and automatically the extension, if you see the symbol that has come for the Terraform, right? And this is where I'm going to write my code, okay, for my Terraform, say the provider. And then where, so we have seen that, okay, there are multiple configuration files there. This is what the configuration files is on the left hand side, this provider, or say main.tf. I will show you that, okay, what basic standards are there for the coding. There is no hard and fast rule, but there is a recommendation, so that while writing you have the clarity that, okay, what I am doing it and what this file is basically doing it. So what you are going to do is, always whenever you are running or writing your Terraform, all the files should be under one folder. Okay, like if you have seen here, for this batch I have created, say, tf Azure as a main folder. Now in that, I am going to start creating multiple folders as we move forward, and in each folder I will be just putting all my configuration files. Okay, that means my provider file and my other files which I am if I want to write it down, resources, and generate the resources or infrastructure, whatever is needed, that will be under one folder. So here, if you have seen, I have created a subfolder called my first code. Okay, like say our first code which we are going to write it down. So that is going to be a folder. In that, now I'm going to put all the files, so that whenever I want to compile, Terraform is going to look for all the files in that folder. Okay, and it will see that, okay, all the files are available. So when you are compiling it and executing it, it will look for the files in that folder only. It will not see the file which is outside the folder. Okay, so in the same directory, your all the files should be present for the Terraform code. So that is another basic thing which we are going to, which you need to keep in mind. Now next, let's talk about the Terraform plugin based architecture, like architecture on which Terraform works. Okay, so right now basically we have got the Terraform binaries there. Okay, the compiler in place. We have got the interface where we are going to generate the configuration files and all. But till now, we haven't configured any kind of authentication or anything where the Terraform is going to connect with the cloud provider, right? Even if I write my code, how it is going to know that where it needs to go? If it is, say, your AWS account or Azure account or so, it cannot be a generic one, right? You should have the authentication, like whenever you are registering the cloud account, you are giving multiple details there, and those details needs here to be configured somewhere, right? So how that is going to be there, and once you have configured it, then how the communication happens with your login credentials and all. So that is where your Terraform plugin based architecture comes into picture. So right now, if you see, you have got the Terraform core in place. That is the first component, which is basically the compiler, which is used for parsing your Terraform configuration, right? So this is basically the Terraform binary, which you got it from the HashiCorp. Then once you have given the credentials, okay, or even though if you haven't given the credential, you have just put that, okay, this is the provider you are going to use, then it is going to connect via remote procedure call with the provider. Now, where are these providers? These providers, or say the plugins, are maintained at the HashiCorp site, but these are all maintained by the specific providers. Like for Amazon, AWS, they are going to maintain their own plugin, but they are going to keep it on the HashiCorp side. Same way for Azure, the plugins will be maintained by Microsoft only, but they will be kept on the HashiCorp side. So that is where you will be getting the plugin. Depending on wherever you are, the plugin you will be getting it. These plugins are also written in the Go language. What is the use of this plugin? These plugins are basically the one which are used to communicate with the resources in the respective cloud provider. That means between my Terraform core, say the compiler which I am having it, and the resources which I want to create, in between there is a communication channel which is nothing but the plugin, which will get downloaded to your machine, and from there it starts communicating with your cloud provider and the resources in the cloud provider. Okay, so they via libraries and all, these are the APIs which are available. So for each and every resource in the cloud provider, the corresponding APIs are available, okay, which is created and maintained by the cloud provider itself. Now your entire Terraform works on this API. So once you have configured it, the plugins will get automatically downloaded. Once it is downloaded and your authentication, whatever you have given, with that, it starts communicating with the resources via APIs. And these are like all secured access, HTTPS based access. So this is the entire architecture of your Terraform. And this is like the architecture on which your Terraform works. So the important things are the Terraform core, which is the binaries of Terraform, then the plugin which you are going to download it once you invoke the provider, which will be downloaded in your local machines. We will see that too. And then once the authentication is done, then it is going to interact with various resources in the API. Like suppose I want to create a resource manager, or I want to create a virtual machine there. So each virtual machine is having its own API. With your authentication, it checks and it start working on that. And then once it is there, it will start provisioning those resources, or whatever the resources you wanted, the size, shapes, and all those things, the disk and all those stuff. That is what it is going to use it, right? So your Terraform core is going to communicate with the plugin. RPC is remote procedure call. Okay, that is where it starts communicating via plugin and interact with your providers. So there is an communication flow here. If you see, this is a high level communication flow from the Terraform binaries to the plugin, then via Golang, which is written. Okay, it goes to the client SDK. So your all the software development kit client SDKs are there, and through that it is going to communicate with the remote APIs. Right. So this is the entire communication flow of your Terraform. So the plugins are the one which is basically as the communication link between your binaries and your actual APIs. So they are the mode of communication through which they are going to interact with the APIs and start the provisioning. So that's why it is mentioned as a plugin based architecture, right? So whatever you are basically configuring it. Okay, so right now we have say configured the Terraform binaries. Okay, and now when we are going to say write our code, first code, okay, then automatically it is going to download the plugin based on the provider which we are selecting. Okay, so let me just write a simple code here. Okay, okay, don't worry about this right now. I'm not writing the code. I'm just putting the standard provider which we are going to use. Okay, just to show you about like how the plugin works. Okay, so you don't have to basically start writing it, because this is where we are going to write this n number of times. A few things are optional here, so still I am just writing it. Okay, and this is where I will be closing it. Okay, so this is where my okay, I will explain you a bit here as well, don't worry. Let me just, and this is all standard one, so this is we are writing it right now, but next time we are going to just copy paste it. Okay, so Now this is, as I mentioned, that you need to basically first get the binaries and then, decide that which provider you are going with. Okay, so we are going with Azure provider. Okay, that is what we have mentioned it. Now what you need to put it here is, this is the standard code for getting, you are going to use it for the Terraform version as well here. So if you see here the Terraform, which I say that, okay, the required version which will be greater than 1.0.0, and then that is where I'm going to use the Terraform version. And this basically gives me that, okay, what all providers I'm going to use. We are using Azure here, so I have put the version of Azure that it should be greater than 2.0, the plugin version. Okay, the Azure plugin will get downloaded, so that will be greater than 2.0, because Terraform has got the version, plugin has got the version. So you need to provide version at each place, and whatever version you are comfortable with, or usually I recommend it whenever you are starting it for the first time, give the latest. So even if you don't give this version here, this is all going to be the latest one it is going to download. So okay, this version is optional. Usually for the first time you don't give it, let it download the latest one. Okay, now to start with, this is what the mandatory code which you need it. Okay, depending on your provider or whatever it is, this is the mandatory code for starting the Terraform, right? We will again go through all these things, step by step way, in the detailed way. Okay, right now I just have put that to show you how the plugin architecture works. So in VS Code, we have got an open in integrated terminal. When you click that, it will open the command line interface here. Okay, now I am just initializing this Terraform, which is first going to download the plugin. Okay, so I just say Terraform init, and here if you see, it has downloaded the plugin, initialize the provider plugin. Okay, let me just show you what it is doing here. Let me just put that up. Right, so if you see here, it has downloaded so here it has basically downloaded the Azure plugin. If you see the plugin version, this is 3.5.0. Now, if you see here where this plugin got downloaded, it is in the hidden directory .terraform got created, and your plugins are here. So this is your plugin which got downloaded. This is an executable file, right? So so right now I have not given any kind of credentials at any point of time. Okay, it is a generic plugin depending on the provider which it is going to download. Right, so till now, this is where our plugin has been downloaded. Now, if you see this architecture, so our Terraform core is there now. Okay, binaries, we did it. Just writing the simple code, we have downloaded the plugin. So this plugin is also now into picture. So now the next part, the last one, the third one comes is communicating with the cloud vendors API. Okay, so your plugin is ready right now to communicate with the APIs. But for that, what you needed is the authentication. That means it can be your Azure account, it can be my Azure account. So that is where, when you are creating, say, a resource manager, or say creating a virtual machine, in which account it needs to go and create the virtual machine, that information your plugin should know, right? That where it needs to create that. And that is where your authentication comes into picture. Okay, so you have to authenticate it. You need to give your credentials, and then that is how it is going to create the login and create the resources in your account. Now there are multiple ways of giving the credentials and all. Okay, let me just move ahead. Yeah, so here you can see, this is where we are giving the providers. Okay, so provider, this is for the AWS. Okay, we are giving the configurations there. For the Azure, we have seen it, the Azure RM, and then the features. So we are enabling with the default features. I will show you in the next class about the features, that okay, what this feature basically is going to help you, and what is the basic about it. Okay, so I am just restricting myself to the architecture right now, not going to the next level. Right, so there are multiple providers are there. Depending on your requirement, you can select it. So this is where on my local machine I have got the files. You can see I have written the provider.tf and all, which is basically going to communicate with the provider via Terraform, and via API calls is going to perform all my setups depending upon what I am looking for. Okay, Terraform basically depends on the desired state, okay, the end state only. So if you see here, I am creating the EC2 instance, but nowhere I am giving it means how to reach to that desired state. Okay, I just say that okay, I need the EC2 instance with so and so configuration, or I need a virtual machine instance with so and so configuration. Now how that is created and how that is going to work, we are not going to define. Okay, we are only giving the high level things that okay, in this region we need it. This should be our shape. This is what we need, the disk space on that and all those things. But we are not defining that okay, how you are going to reach there. So we are always going to give the end state, and that is where the initial concept which we have gone through, that okay, your Terraform works on that concept, is in line with that. Okay, so Terraform basically works on the end state only, and via API calls it is going to, for each provider, the resources, basically you have got the APIs available, so you are going to communicate with the APIs. Right, so this is a generic one which basically defines that okay, what is basically required. So we have seen that. Okay, but absolutely don't worry about it at all. Okay, so right now I am just focusing on the plugin based architecture. Okay, now provider versions we need to provide it. That is where you can see, which is an optional thing, but you might be coming across certain symbols here: greater than, equal to, less than, equal to, or tiddle greater than sign, which basically has got some version. So any version, like say here 1.41 and above, will get downloaded when you are giving the specifying the version. Here maximum version will be 1.41, but any version less than this, if available, will be downloaded. Tiddle sign, now this why I'm explaining this is, this can be one of your objective question too. So tiddle sign basically gives you range, like you can get it from 1.4.1.41 will be the fixed one, only the last version will get changed. Okay, so this is important. So last version is, I say, 0, 1, 2, 3. If you are putting it greater than sign, then it means that anything which is available of the higher version will get downloaded. Or even you can give the range greater than 1.20 and less than 1.41. So this is all for downloading the plugin version. Okay, and as mentioned, as a standard practice, you always start with the latest one, and then later you are only moving to the next one as and when needed. Okay, now for the authentication purpose. Okay, so next comes is then authentication part. Okay, now there are multiple authentication methods available for authenticating with the provider. We will see that in our next session, but yes, the generic method is for Azure. If you are, say, working on the Azure, as we will be doing it, you need to download the best practices. You need to download the Azure command line interface. Okay, so once you have downloaded the command line interface, directly from the command line interface, you can authenticate it, and that is the best approach, because that is not going to save your credentials at any place. Okay, it is like you're logging to your Microsoft account from the console, and that is going to authenticate it, and your Terraform will be all ready to work. Okay, so what basically is done on the, once you have downloaded and configured the command line interface, then you can basically just do the AZ login here. And once you do the AZ login here, it will open the browser, and where you will be giving your Azure account credentials, and that's it. It is all going to be login and will authenticate your Azure account. That is the best way and most commonly used way. Now, apart from that, the subscription and all those will be used. We will see those things as well. But right now, let's keep it here for the AZ login. So what you need is further, you need to download and configure. If you are using Azure, then Azure command line interface you need to configure, and that is where it is going to. For AWS, nothing is required on the command line interface. Best approach is to authenticate it with the environment variable on the AWS side. So here, if you see, I have got my environment variables here, AWS access key ID and AWS secret access key. If you just configure these things at your command line in your environment variables, then you don't need to authenticate your AWS further. It will automatically gets connected, and you don't have to specify your login credentials and everything in the code as well. It will directly take it from here. So you can just see the activity guide as well, where we have just put all these things with the screenshots.
So guys, I hope you really liked our session. If you're somebody who's completely new and you want to study the exam content from start to finish, then please check out our free class at k21academy.com/terraform02. Under this free class, we'll be covering a lot of topics like cloud and DevOps overview, cloud automation tools, Terraform, CloudFormation, Ansible, Chef, Puppet, infrastructure, automation, IAC, Terraform for beginners, what, why, and who should be learning, Terraform certification, extending Terraform with Ansible, Chef, Puppet, etc. We'll be giving you a demo of VM deployment in AWS Cloud using Terraform. And the best part is, we'll be covering a lot of job opportunities and how you can get better pay in your Terraform job. So, all you have to do is just log on to k21academy.com/Terraform02 and click on book your free seat now. Select your event date when you're available. Moving ahead, add your name, your email address, your phone number, and click on yes, proceed ahead. Now you'll be seeing this kind of link at the extreme right. Save this link, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.